So this is my video of how to assemble one XOR gate. So as you can see here, here's my breadboard hooked up to an Arduino, which is hooked up to a USB port just for power. This is just a power source. And I have ground and 5 volts. And you see 5 volts, the red wire, and ground, the white wire. This red wire is flowing into my positive rail for my breadboard, and this white wire here is flowing into the negative rail. So if we look at the setup here, this XOR logic gate here is actually this little boy here. This is just so I can zoom in on it. This is what I got from Texas Instruments, serial number 74 HC 86N. And you can get these pretty cheap, like I said, from Texas Instruments or from whatever transistor manufacturer you like. And here's a diagram of how to look at the pins here for this XOR gate. As you can see here, let me just arrange this a little bit better. As you can see here, logic gate here. As you can see, there's 7 pins on both sides, either side of the logic gate, corresponding to 4 sets of XOR logic gates, as well as a ground and a VN. So as you can see here, this little pin right here is your VN, and this little pin here on the end is your ground. And you might be able to see this little divot in the top of the transistor, and that little divot denotes, I guess, at the top of the transistor, so you know how to orientate yourself. So like I said, this is 4 XOR gates. Let's see here. And so for these first top 3 pins here, 1, 2, 3, this is your input 1, your input 2, and then your result 1 rather. So excuse me, your input A1, your input A2, your input A1, your input 1B, and then your output 1Y. So just to diagram that, you have 2 inputs, 1 output. This is your Y value, this is your A value, this is your B value, and this is an XOR gate. And so the truth table for this is as follows. It's an exclusive OR gate, which means that it should only be on when only one of the pins is on. So if I have 0, 0, well, none of the pins are on, so I have 0 for my result. If I have A on, but I have B not on, then I have only 1 pin on, so I get a 1. And likewise, if I have B on but A off, I will also get a 1. But if I have both on, I will get a 0. And this last feature here is what really distinguishes the XOR gate from the regular OR gate. So the regular OR gate would actually have a 1 here. The exclusive OR gate, or the XOR gate, has a 0. So back to the circuit. This is just to give you an idea of how to actually use one of these bad boys. So as you can see here, This white cord here connects my ground, right? So this is my ground pin to the ground rail here. And then this is, this pin here is an, this pin here, this one connected to this resistor. Get my camera back. As you can see, that is my output 2, which is actually this one, so number 6, the 6th pin. And I've connected that to a resistor, right? I've taken it off to its own separate vertical rail, and then I've connected a LED for the result, so I can tell what's going on here. So just a reminder, make sure that you've connected the LED correctly. So LEDs have a positive and negative terminal. The negative terminal is the shorter terminal, and the longer terminal is the positive terminal. So what you need to do is make sure that this positive terminal, this longer terminal, is connected into the resistor rail, and then this negative terminal is connected to ground. So now for pin number 5, this is our input. This is pin number 5 here, number 5. We have that connected here to a little dip switch here, as you can see. And we also have pin number 4, or our second input, pin number 4, also connected to its own dip switch here. So you can see this dip switch is connected to this one. This dip switch is connected to this one. You can see that. You get a little bit of a closer view here. Here. Alright. So these two dip switches, right, connected to these two. Right. And then we ground out our dip switches through a resistor. I've found that you kind of need these two resistors to ground out the dip switches. I've tried to use regular cable. It hasn't really worked as well. But so we ground out the dip switches with these resistors. And we just put in the same rail and put it to the ground. And then likewise, we connect our dip switches to power. So we go ahead and connect our dip switches here to the power rail, as you can see here and here. And finally, we connect our gate right here to its own power source. So it's VN pin here. This VN is this VN here, pin 14. So that's kind of a look at the circuit. And now let's see if it works. So remember our truth table for 0, 0. We should get 0. So you can see here, both are off, and we have no light. So now let's go one of these switches on. Make sure that my finger, oh no, my finger just, okay, there you go. So now we have, as you can see, one on and one off, and we have the LED on. It's very bright. Probably need more resistance there. So now let's turn both switches on. And as you can see here, both switches on and no LED light on. Okay. So now let's turn this original one off. Okay. So now we have one on, and yeah, the LED is now back on again. Okay. And now, finally, let's try both on. See, both are on, and no LED light. So as you can see, we've validated that this table holds. Right now, we're in the 1-1 case, and this is giving a 0. So on, and we have 0 out here. This is a little bit deceiving just because, like, this dip switch has a 1 at the bottom, which seems to imply that this, you know, seems to be relevant for this one, but it isn't. This one just denotes an on position, which corresponds to, of course, this. Okay, so that's about it. Hope this video was helpful.